Bismillahirrahmanirrahim. Institute of Southern Punjab, Multan, Department of English. The subject is elementary mathematics, and this lecture is for BS English semester 2nd, and this is the lecture number 3 for elementary mathematics. Okay class, in this lecture we will discuss the relation and functions. I guess हम already Cartesian product of फंक्शंस पढ़ चुके हैं, तो कार्टेशियन प्रोडक्ट के बाद ये हम रिलेशन की बात करते हैं। रिलेशन जो है वो हम पहले भी थोड़ा सा उसको डिस्कस किया था। रिलेशन की ये डेफिनेशन है, अ रिलेशन आर फ्रॉम अ सेट ए टू बी इज़ एनी सबसेट ऑफ ए क्रॉस बी इफ बी इज़ इक्वल टू ए। तो फिर हम इसको इस तरह से लिखते हैं और हम कहते हैं कि पेयर ए बी जो है वो आर से बिलोंग करता है। देन वी से दैट ए इज़ रिलेटेड टू बी एंड राइट ए रिलेटेड टू बी, एंड इफ ए इज नॉट रिलेटेड टू बी तो फिर इसको इस तरह से लिखते हैं ए बी डज नॉट बिलोंग टू आर। देन डेफिनेशन थी डोमेन ऑफ अ रिलेशन की। द डोमेन ऑफ अ रिलेशन आर इज द सेट डी ऑफ आर सच दैट ए बिलोंग्स टू ए एंड ए बी बिलोंग्स टू आर फॉर सम बी बिलोंग्स टू बी। एंड द डेफिनेशन फॉर रेंज ऑफ द रिलेशन, डोमेन के लिए डी ऑफ आर लिखते हैं, रेंज के लिए आर ऑफ आर लिखते हैं। और इसमें हमारे पास क्या सेट होता है, बी बिलोंग्स टू बी सच दैट ए बी बिलोंग्स टू आर फॉर सम A belongs to A। ठीक है, डोमेन में हमारे पास फॉर सम B belongs to B, इसमें फॉर सम A belongs to A। एंड नेक्स्ट वी हैव एन एग्जांपल फॉर रिलेशन। एग्जांपल नंबर 1, वी हैव अ सेट A which has 3 entries 4, 5 and 6, and B set has entries A, B, C and D. Okay, then we write a relation from A to B, 4A, 4B, 5D and 6B. Then we find its domain and range of this relation. Its domain is 4, 5, 6. Okay, the first number which belongs to the set A are the domain of the set, and the second number which belongs to the set B are the range of the relation. Next with example number 2. In this example, a set A is given 2, 3, 4, 5, and A is related to B if A is divided by B. Then A cross A, we find the relation from set A to itself. Then we have to find the pairs of set A to itself. Firstly we write the pairs of 2 with 2, then pair of 2 with 3, then pair of 2 with 4, and then pair of 2 with 5, and so on. 3, 2, 3, 3, 3, 4, 3, and so on. Okay, this is the relation of set A to itself. Then we find relation of A to itself, 2 of R, 3. Then there is a relation, if A is divisible by B, then A is related to B. We have a relation in which A should be divisible by B. So in this set class, you can see that only 2 can divide 2, and 4 can divide 2, and 4 is divisible by 2, 4 is divisible by 4, and 5 is divisible by 5, and 3 is divisible by 3. So we have the relation these numbers, and the domain of relation is equal to 2, 3, 4, 5, and range of relation is also 2, 3, 4 and 5. We have to decide the domain and range from this set, a relation set. In this relation set, you can see that 2 is related to 2, so the first number which is 2, this number will belong to the domain, and the second number will, okay, and then range of R is equal to 2, 3, 4, 5, and this is the range. Next we have a type of relation. A relation R on A is said to be reflexive if A is related to A, and if two numbers in a relation in a Cartesian product also belongs to the relation, then we say that this relation is reflexive. If 2, 2, 3, 3, 4, 4 such numbers are in a relation, then we say that this relation is of reflexive type. And the second type is symmetric type of the relation. Okay, we define symmetric type if AB belongs to R, if and only if BA belongs to R. If 1, 2 is in relation R, then 2, 1 should also belong to the relation R. Then we call this relation is symmetric. Okay क्लास, इन मतलब यहाँ पे हमारे पास ये थोड़ा सा ट्रिकी है इसमें कि हम कहते हैं कि इफ़ एंड ओनली कंडीशन, मतलब अगर 1, 2 रिलेशन आर से बिलोंग कर रहा है तो हमारे पास 2, 1 भी रिलेशन आर में होना चाहिए, तब उसको सिमेट्रिक। अगर एक कंडीशन होल्ड हो रही होगी और दूसरी नहीं होल्ड हो रही होगी तो फिर वो सिमेट्रिक नहीं होगा। द नेक्स्ट डेफिनेशन इज for symmetric, if and only if AB belongs to R and BC belongs to R, then AC belongs to R. Mean if we have AB, let's suppose 1 and 2, pair of 1 and 2 belongs to R and pair of 2 and 3 belongs to R, then we say that 1 and 3 will also belong to R. 1 and 3 should also have to belong to R for the transitive kind of relation. Then we call this relation is transitive, otherwise we say that this relation R is not transitive. Okay, then next definition is antisymmetric. If AB belongs to R and implies that BA does not belong to R, then this relation is called antisymmetric. This is actually converse of symmetric properties, converse of symmetric relation. In symmetric relation we say that a function is symmetric if AB belongs to R. If AB belongs to R, then BA should also belong to R. But in antisymmetry, we have one condition and the guarantee, there is no guarantee for the other condition either holds or not. If AB belongs to R, then it is not necessary that BA will also belong to R. So this type of relation is called antisymmetric. And then next definition is an equivalence relation. Okay, what we say in an equivalence relation, a relation is called equivalence if it is reflexive, symmetric and transitive. So this is here is the definition. It is reflexive, symmetric, mean a relation is called is called transitive if it is a relation is called equivalence if it satisfies the property of reflexive, symmetric and transitive. Then we say that this relation is an equivalence relation. Mean if we have to prove that a relation is an equivalence relation, then firstly we will prove that this relation is reflexive, secondly we will prove that that relation is symmetric, and thirdly we will prove the transitive property for that relation. Okay, and next we have another topic, another important topic, and this is called the function. It is a rule which connects each element of a set A to a unique element of set B. Okay, mean function is a rule which connect each element of a set A to a unique element of set B. Mean function is a kind of a relation or connection in which we say that we have two sets A and B, and between sets A and B there is a connection. This connection is called a function if it satisfies two properties. What are the two properties? The two properties are these, that each point of set A should be connected to some point of B. Okay, and the connection should be unique. Connection should be unique between two sets. Then we say that this connection is called function. Okay, next we have types of functions. One function is also known as an injective function, distinct elements having distinct images in one function. Or let fa approaches to b a function. We say that f is one-to-one function if for all ab belongs to a is not equal to b, then f of a will not equal to f of b. Mean if a and b are different or distinct numbers, then their images will be distinct. Mean if a is not equal to b, then f of a will not equal to f of b, and if a is equal to b, then f of a will be equal to f of b. Okay, the next type is onto function. A function f is onto if for all y belongs to b, there exists x belongs to a such that f of x is equal to y. Okay, what we say in an injective in onto function, we say that a function f is onto if every element in the second set B have an image in set A. Okay, f is onto if every element in second set B for all y belongs to B, there exists an element x belongs to A such that f of x will be equal to y. Mean आपने B सेट में जितने भी नंबर्स हैं उनके लिए ए सेट में कोई ऐसा नंबर एग्जिस्ट करना चाहिए कि उस ए सेट के नंबर पे जब आप फंक्शन अप्लाई करें तो वो बी सेट के नंबर के इक्वल है. ओके, देन इसकी जो सेकंड डेफिनेशन, इस डेफिनेशन को हम इस तरह से भी लिख सकते हैं. लेट एफ ए अप्रोचेस टू आर बी फंक्शन, देन द फंक्शन एफ इज सेड टू बी ऑन टू फंक्शन इफ फॉर ईच एलिमेंट इन को डोमेन देयर एग्जिस्ट एन एलिमेंट इन डोमेन ऑफ द फंक्शन. दिस इज द डेफिनेशन ऑफ ऑन टू फंक्शन. Okay, then we have the definition of bijective function. A function f is said to be bijective function if f is 1 1 and onto function. Clear? mean if a function satisfies the properties of both one function and onto function, or in other words, if a function is injective and surjective at the same time, then this function is called bijective function.